Our topic right now is Chapter 5, States of Matter, Part 1, Gases and Liquids. The liquids, solids, and gases, the particles of solids arranged in regular repeating patterns. They are held firmly in place but can vibrate within a limited area. For liquid, the molecules flow easily around one another, kept from flying apart by attractive forces between them, and the liquids assume the shape of the containers. For gas, the molecules that make up a gas fly in all directions at great speeds. They are so far apart that the attractive forces between them are insignificant. For gases have no fixed shape or volume. The particles fall apart, therefore gases can be compressed and are randomly arranged, can move freely from place to place in all directions. Liquid particles are close together, have a fixed volume and can be compressed lightly, arranged very randomly, have limited movement from place to place in all directions. Solids have a fixed shape and volume. The particles are touching each other. The solid cannot be compressed. They are usually in a regular arrangement, then cannot change positions with each other. They can only vibrate. Kinetic theory of gas states that molecules of gas move rapidly and randomly. The distance between the gas molecules is much greater than the molecules, so the volume of the molecules is negligible. Third, there are no forces attraction or repulsion between the molecules. All collisions between particles are elastic. This means no kinetic energy is lost in collision. The temperature of gas is relating to the average kinetic energy of the molecules. Ideal gas and real gas. Ideal gas is a theoretical gas that fits the description of kinetic theory of gas. But in reality, the gas we encounter don't fit this description exactly, although they may be very close. The gases we encounter are called real gases. And we come to the general gas equation or ideal gas equation. You know this, the PV equals nRT. P is pressure, volume, V, N is the number of mole, R is the gas constant, the value is 0.0821 in unit ATM liter per mole Kelvin, or R can be 8.31 kilopascal mole per kilopascal liter per mole Kelvin. So we can use this formula for calculation in different units. You need to remember 1 ATM is 101.3 kilopascal. There are some limitations to the ideal gas law. Scientists have taken accurate measurements to show how the volumes of gases change with the temperature and pressure. This shows us that gases do not always behave exactly as we expect an ideal gas to behave. This is because real gases do not always obey the kinetic theory in two ways. The first, there is not zero attraction between the molecules. So there will always be attraction force between the molecules. The second reason is we cannot ignore the volume by the molecules themselves. These differences are especially notable at very high pressures and very low temperatures. Under these conditions, the molecules are close to each other. The volume of the molecules is not negligible compared with the volume of the container, and there are van der Waals or dipole-dipole forces of attraction between the molecules. The attractive forces pull the molecules toward each other and away from the walls of the container, and the pressure is lower than expected for an ideal gas. The effective volume of the gas is smaller than expected for an ideal gas. The liquid states, the behavior of liquids. When we heat a solid, the energy transferred to the solid makes the particle vibrate more vigorously. The forces of attraction between the particles weaken, and the solid changes to a liquid when its temperature is sufficiently high. When we cool a liquid, the particles lose kinetic energy, so they do not move around so readily, experience increasing forces of attraction, and then stop sliding past each other. When the temperature is sufficiently low, the liquid solidifies. Vaporization and vapor pressure. When we heat a liquid, the energy transferred to the liquid makes the particles move faster. The forces of attraction between the particles weaken, and the particles with most energy are the first to escape from the forces holding them together in the liquid. The liquid evaporates. This happens at a temperature below the boiling point. The forces weaken enough for all the particles to become completely free from each other. They move fast and random and they spread out. The liquid boils. This happens at the boiling point. This changes from liquid state to gas state is called vaporization. Condensation. When we cool a vapor, the particles lose kinetic energy, so the molecules move around less quickly. Then experience increasing force of attraction, move more slowly and become closer together. When the temperature is sufficiently low, the gas liquefies.